Welcome to third part of NB-IoT videos. So we have discussed in the last two videos about the basics of NB-IoT and then power saving mode. Here we are going to discuss about various timers and timings of NB-IoT operations. Timers. This is a short explanation of the functional timers in cellular connection. The three timers that will become relevant later in this section are periodic TAU timer. Timer that the UE will stay in power saving mode before waking up to send the tracking area update to the network. Active timer. Timer that the UE is monitoring paging in RRC idle mode before going to PSM, that is power saving mode. RRC inactivity timer. Timer that UE stays in RRC connected mode after transferring data. After this time, the UE receives the event RRC release from the network. Understanding the different timers and the different connection status and modes is important for understanding and calculating the power consumption in your application and for debugging your cellular application. Power saving mode, PSM. Power saving mode is a state where the UE reduces its power consumption to a bare minimum to stay connected by going into sleep mode. In PSM, the UE is on monitoring paging and as a result becomes unreachable. To avoid the reconnection procedure when waking up again, the UE is allowed to keep the connectivity status. For this to happen, the UE must wake up regularly and send a tracking area update to the network. This period is decided by the period TAU timer. A UE in PSM will wake up for one or two reasons, either triggered by the periodic TAU timer to send a TAU or the application to turn UL messages. Either way, the device wakes up, enters RRC connected mode, sends and receives data packets, then stays in RRC connected mode until the RRC inactivity timer has run out. Then it will go to RRC idle mode for the active timer period to monitor paging before going back to power saving mode. This image gives a graphical representation of various timers. The dark blue, the leftmost bar gives the data transfer period and the next lighter blue gives the connected. It remains connected but there is no data transfer in this area. This is known as RRC inactivity timer. Then is go to active time paging mode. It does three pagings and then in the dark blue region is go to power saving mode. The height of the bar indicates the power consumed by the UE. The yellow region is RRC connected mode and the red region is idle mode. The difference between using PSM and simply turning off the modem is that in PSM the UE can still be configured to wake up to update the network about its status and stay reachable for a while. The advantage of PSM is that the UE goes into deep sleep and the radio only consumes a few microamperes. The UE does not lose its connection information on the network, meaning that upon UE wake up, the connection is established relatively quickly. This reduces the power consumption compared to power off modem waking up and having to re-establish the connection with the network from scratch. EDRX. As we mentioned earlier, DRX, discontinuous reception, is a method where the UE and the network negotiate phases in which data transfer occurs. The UE wakes up regularly to check with the network if it has any incoming messages, that is called pages, and will otherwise go into sleep mode. However, the sleep time is only around 2.5 seconds, which can work well for cell phones, but when it comes to IoT devices, DRX is not enough. Extended discontinuous reception, EDRS takes the step further by extending the amount of time the UE can sleep before having to wake up and check for pages. Note that the device is not reachable while it is sleeping, so the time it takes to reach the device depends upon duration of the EDRX cycle. The image in the next slide shows two different scenarios for EDRX connection status. On the left, the UE is waking up to monitor pages without having any. On the right, UE wakes up to a page that requires a data transfer. In RRC connected mode for the duration of the RRC inactivity timer before monitoring paging and going back to sleep until the next EDRX cycle. Similar to the previous image, the leftmost image is the data transfer region where the power is consumed more. The next is current and mode, but where nothing happens in this area. Then there are EDRX mode where the paging is happening. Then in the dark blue mode, then power saving mode where the EU sleeps goes into deep sleep mode. Different use cases. To put it very simply, the difference between PSM and EDRX is how deep the device sleeps and for how long it can sleep. PSM sleep times are much longer than EDRX, allowing the device to enter a deeper sleep which consumes less power. The downside being that the device will take longer to wake up and it will be active for a much longer period of time. With sleep, we mean that in PSM the radio turns off both RX and TX while it is still registered to the network. In EDRX, TX is turned off and RX is intermittently turned on to listen for paging messages. When the UE is sleeping, the application core can still be reading sensor data or other operations that don't involve the modem. So this slide concludes this part of NB-IoT. This is yet to be completed in many more videos. Please keep watching this channel for the further updates. Thank you for watching. See you. Tata. Bye bye for the next video.